Look up at the night sky for a moment in your mind. Imagine the stars scattered across the darkness, each one glittering like a secret. There's a certain peace in that view, isn't there? A reminder of how small we are, how vast the universe feels, how mysterious intelligence can be when we start to wonder whether we're the only thinking beings out there. But as our eyes rise to the heavens, most of us forget that another universe of brilliance lies not above, but below, hidden in the quiet sway of the ocean. Beneath those same stars, under the surface, something extraordinary is unfolding. Coral reefs, places you might associate with color and fish and tropical vacations, hold a kind of intelligence most people never consider. And tonight I want to let you in on a secret. Coral reefs are smarter than you think. That statement might sound impossible. After all, corals aren't animals with brains, they don't write equations, they don't solve puzzles the way dolphins or octopuses do. At first glance, they look more like underwater rocks than anything worthy of the word smart. But what if intelligence isn't only about neurons firing? What if intelligence can be a way of surviving, adapting, organizing, and shaping an environment with such precision that it creates one of the most complex systems on Earth? If that is intelligence, then coral reefs may quietly be among the most brilliant engineers, collaborators, and innovators this planet has ever seen. Consider the contrast. When we think of genius, we imagine the lone thinker scribbling notes, or the inventor tinkering late into the night. But reefs are different. Their genius is collective, silent, and patient. They don't hurry, they don't boast, they don't even look alive at first. Yet, piece by piece, they construct structures that can be seen from space. They design neighborhoods for thousands of species. They optimize light, nutrients, and flow in ways that rival our most advanced technologies. You may be tempted to dismiss them as primitive, but to do so would be to underestimate a hidden form of intelligence that rewrites the rules we've been taught to believe. And isn't that a little unsettling? We spend our lives chasing what we call smartness, grades, IQ scores, accolades. But reefs show us that brilliance doesn't always look like human cleverness. It looks like cooperation, like resilience, like being able to adapt without losing balance. It looks like symbiosis so seamless that two different organisms essentially become one. When you realize that, you start to see smart less as a competition and more as a dance with the environment. And suddenly, a coral reef becomes less of a backdrop for tropical postcards and more of a teacher whispering from beneath the waves. Now, I want you to hold on to that tension because it opens a door we rarely walk through. How can something without a brain behave in ways that feel so intentional? How can something so seemingly simple carry out tasks that mirror the strategies of our own societies? These are not questions with immediate answers, but they are the kind of questions that keep curiosity alive. They force us to widen our definition of intelligence beyond the human ego. They remind us that sometimes, the universe hides wisdom in places we're least likely to search. And tonight, that wisdom is waiting for us in the hidden glow of coral. The first spark of that wisdom is revealed when you shift perspective. Picture yourself floating on the surface of warm, still water, stars overhead. Beneath you is a reef, unseen in the darkness, yet alive with quiet work. Tiny creatures no bigger than a match head are busy, each one carrying out its part, none aware of the vast city it is building with others. Doesn't that remind you of us? Billions of humans, each living their own small life, rarely aware of the larger pattern we form together. We call our cities evidence of human brilliance. But coral, without any leader, without blueprints, without intention in the way we understand it, accomplishes something eerily similar. It makes you wonder who really owns the monopoly on being clever. This is where identity begins to shift. If intelligence is not only about abstract thought but about creating balance in chaos, then reefs are role models. If it's about finding ways to thrive despite obstacles, then corals embody it every single day. And if it's about building systems that last across centuries, then these underwater architects might deserve more recognition than we've ever given them. Suddenly, the question changes from "Are coral reefs smart?" to "What can we learn from their intelligence?" That shift is powerful because it invites humility. It invites us to see ourselves not as the pinnacle of evolution, but as students of it. And here is the promise I'll make to you. By the end of this journey, you won't just admire reefs for their beauty. You'll see them as complex minds in their own right. Minds without brains, but with strategies and wisdom that stretch across millennia. Minds that can teach us about resilience, about cooperation, about surviving in a world that's constantly changing. Right now, you may be skeptical, and that's good. Curiosity grows best when it has something to challenge. But keep listening, because the deeper we go, the more you'll discover qualities in coral that mirror some of the smartest choices life has ever made. Above us, the stars still shine, timeless, constant. We've always looked to them for meaning. But beneath those same stars lies a brilliance of a different kind, a quiet, patient genius that has shaped our oceans for millions of years. Coral reefs may not write books or compose music, but in their silence, they are telling us a story of intelligence we can no longer afford to ignore. And tonight, under this starlit sky, you and I will dive into that story together. If you look closely enough at the surface of a coral, you'll see that it isn't a single thing at all. It's a gathering, a neighborhood of tiny beings known as polyps. Each one is small and fragile, almost insignificant by itself, but together they create something extraordinary. Think of a single brick. Alone, it doesn't tell a story. It's just material, a block of potential. But when you start laying bricks side by side, carefully stacked, arranged with patience and purpose, they begin to form walls, archways, whole structures. Coral polyp is that single brick. And yet, unlike us, it doesn't wait for an architect's blueprint or a construction crew. The plan is already within it. By simply doing what it was made to do, it contributes to the rise of an underwater city that will outlast generations. Now imagine those polyps multiplying, each one secreting calcium carbonate, the same material found in limestone. At first, it's nothing more than a thin coating, but over years and centuries, those coats layer upon each other, forming a foundation as solid as concrete. If you run your hand across it, you're not just touching stone. You're touching the product of millions of tiny decisions made by organisms that never spoke, never voted, never held a council meeting, yet somehow managed to agree on a single design. Isn't that remarkable? Our cities demand committees, planners, permits, and constant debate. Coral cities simply happen. They emerge from cooperation that doesn't need language to succeed. What makes this even more impressive is their precision. Corals don't just grow randomly in all directions. They respond to the flow of water, to the availability of sunlight, to the subtle changes in temperature. They curve toward what sustains them and away from what threatens them. Each polyp is sensitive to its surroundings, but instead of acting selfishly, it contributes to the larger pattern of the colony. And that larger pattern, it's nothing less than architectural genius. Have you ever noticed how human cities, when designed well, account for traffic flow, natural light, and access to resources? Reefs do the same, but without surveyors or engineers. They arrange themselves into structures that allow maximum access to currents, that funnel nutrients to where they're needed most, that give shelter to residents who will in turn support the coral's survival. The balance is breathtaking. If we step back, the scale begins to shift. A polyp by itself is smaller than the tip of your finger. A colony is the size of a hand, then a rock, then a boulder. With time, entire ridges and towers appear, spreading across kilometers. Eventually, the reef becomes a barrier that can be seen from satellites orbiting Earth. And here's the paradox. Intelligence is usually measured by the speed of response, by quick thinking. But corals' intelligence is measured in centuries. They don't rush. They take their time, adding millimeter by millimeter until their creation dwarfs our skyscrapers in both scale and longevity. That is patience elevated into strategy. What does that tell us about what it means to be smart? We often reward urgency, quick problem solving, fast returns. But coral whispers a different lesson. Intelligence can be slow, methodical, almost invisible until you pause to look back and see what has been built. It's the wisdom of compounding effort, the discipline of small actions accumulating into something vast. And maybe that's a kind of genius we could use more of in our own lives. Less obsession with instant results, more faith in the architecture of persistence. The adaptability of reefs adds another layer of awe. Imagine you're building a house, and halfway through the terrain shifts. The ground sinks, the light changes, a storm tears away your roof. Most of us would abandon the project or start over. Corals don't have that luxury. Instead, they adjust their design. They expand in the direction of stronger currents. They flatten to capture more sunlight. They arch upward when light is scarce. They integrate change rather than resist it. Doesn't that mirror the resilience we admire in people who thrive despite adversity? The reef doesn't stubbornly insist on one blueprint. It evolves its blueprint as the environment demands. And isn't that the very definition of intelligence? Adapting in order to endure? Let's zoom in again to the scale of a single polyp. Each one has a mouth ringed with tentacles that reach into the water, pulling in plankton, feeding itself. At the same time, it secretes limestone, laying down the foundation of tomorrow's city. What fascinates me is how each tiny action contributes not just to the individual's survival, but to the legacy of the whole. A polyp that lives for only a few years leaves behind a stone skeleton that persists for centuries, becoming the bedrock for future generations. In human terms, it would be as if every step we took, every gesture we made, left behind a piece of infrastructure for our descendants to use. Can you imagine what our world would look like if every human action was automatically an act of construction rather than consumption? This brings us to a contrast worth reflecting on. When we build cities, we extract resources, often leaving destruction in our wake. Coral builds cities by giving back. Their very act of living creates habitat for others. Their walls become nurseries for fish. Their crevices become hiding places for crabs. Their ledges host sponges and sea fans. In essence, coral polyps are architects who design not just for themselves, but for entire communities. And what does that say about our own designs? Too often, our architecture isolates us. Tall towers that separate the wealthy from the poor, sprawling suburbs that cut us off from one another. Coral's architecture is inclusive. It is built on the principle that survival is shared. Step out again to the macro scale. Picture the Great Barrier Reef stretching over 2,000 kilometers. From space, it looks like veins of light woven into the ocean. From a boat, it looks like scattered patches of rock and color. But from beneath the water, it reveals itself as a metropolis. Imagine New York or Tokyo, bustling with life, intricate networks of streets and towers. Now imagine those cities lasting not for centuries, but for tens of thousands of years. Reefs don't just endure, they thrive across geological time. Some structures began forming before our species even existed. While human civilizations rise and fall, reefs continue their patient expansion, as if reminding us that the most lasting intelligence is the one that invests in permanence. So here's the question that lingers. Why do we overlook them? Maybe because they don't match our definition of brilliance. They don't dazzle us with speed or spectacle. But once you see them as architects, once you understand that every ridge and tower was designed through collective cooperation and environmental awareness, you can't unsee it. You start to respect them not just as ecosystems, but as master builders. And in that recognition, there's an invitation for us. If corals can build cities that nurture, adapt, and last, why can't we? We often forget that our intelligence is not the only kind that matters. We define cities by their skylines, their lights, their constant noise. Coral defines its cities by silence, by patience, by the flow of water through a labyrinth of stone. And yet, one could argue their designs are far superior. They sustain more life than any city we've ever built. They require no external power, no constant repair, no extraction of distant resources. Their genius is self-contained, sustainable by design. If that isn't intelligence, then maybe our definition of the word is too narrow. As we leave this thought behind, I want you to hold on to the image of a single polyp, quietly secreting its limestone foundation. Imagine it multiplied millions of times, stretched across generations, forming a city so vast it shapes coastlines and bends currents. That's the hidden architecture of coral. It may not wear the label of intelligence the way we do, but its cities tell a story louder than words. A story of design without ego, purpose without architects, and brilliance without brains. And in their silence, they challenge us to redefine what it means to build something that lasts. If you've ever lived with a roommate who cooked for you, cleaned up afterward, and never once asked you to pay for groceries, you know how good it feels to have someone in the house who makes life easier. Now imagine that instead of a roommate, it's a permanent partnership, one that has lasted for over 200 million years. That's what coral polyps have with the tiny algae that live inside their tissues. It's more than a relationship. It's a pact, a contract written not on paper but in evolution. And it's one of the most intelligent arrangements in nature. The algae, called zooxanthellae, are microscopic plants that perform photosynthesis. They capture sunlight, convert it into sugar, and hand over a large portion of that energy to the coral host. In exchange, the coral gives them a home, protection, and access to waste products like carbon dioxide and nitrogen. Exactly what algae need to thrive. It's as if the coral provides the kitchen, and the algae serve as master chefs, preparing meals day and night. Together, they form a household where nothing is wasted, where resources are cycled and optimized to perfection. Doesn't that sound more efficient than most of the systems humans have managed to build? The brilliance of this partnership is in its balance. The coral could survive without the algae, scraping by on drifting plankton, but it would never have the energy to build the vast limestone cities we call reefs. The algae, too, could exist in the open ocean, but they'd be exposed, vulnerable, and far less productive. Only when they come together do they unlock their full potential. That's the hidden genius. Instead of competing for survival, they merge into a single cooperative system that benefits both sides. When we talk about intelligence, why do we always imagine a solitary brain? Perhaps the smarter model is collective, where two or more forms of life fuse their strengths to become something greater than the sum of their parts. Think about how we run our societies. We burn fossil fuels, mine resources, transport food across continents, and still manage to waste staggering amounts of energy. Now compare that to the coral algae system. With nothing more than sunlight, water, and patience, they generate enough energy to feed a bustling metropolis of marine life. Every ray of light is converted with near-perfect efficiency. Every byproduct is reused. Every bit of space is maximized. This is an economy without inflation, a supply chain without waste, a power grid that never goes down. When you look at it this way, you start to realize that corals have been running a smarter energy system than humanity ever has. There's something deeply humbling in that. We pride ourselves on our innovations, our clever hacks, our constant pursuit of optimization. But here is a simple creature, brainless and quiet, managing resources in ways that could teach us everything about sustainability. Coral and algae don't waste time searching for what they don't need. They've honed the art of enough. They live within their means, not by limiting themselves, but by creating a cycle so elegant that excess becomes unnecessary. What if our own economies were built on that principle? What if success wasn't measured by growth alone, but by the harmony of exchange? At this point, you might be wondering, if this partnership is so perfect, why isn't it unbreakable? That's the tension we have to hold. For all its brilliance, the relationship between coral and algae is fragile. When conditions shift, when water gets too warm or too polluted, the algae can no longer perform their role. The coral, stressed and desperate, expels them. Suddenly, the kitchen goes dark, the chefs are gone, and the reef begins to starve. This is what scientists call bleaching, a process that strips reefs of color and vitality. We'll dive deeper into that later, but for now, let it serve as a reminder. Even the smartest systems have vulnerabilities. Intelligence isn't invincibility, it's adaptability, and adaptability is always tested. Still, the sheer persistence of this partnership deserves awe. It has survived ice ages, shifting seas, and planetary upheavals. For hundreds of millions of years, coral and algae have worked side by side, quietly shaping the foundation of ocean ecosystems. That's older than the dinosaurs, older than flowering plants, older even than our earliest ancestors' attempts at language. If longevity is a measure of wisdom, then this partnership may be one of the wisest strategies life has ever devised. But let's make this personal for a moment. Think of the relationships in your own life, the ones that elevate you, sustain you, make you more than you could be alone. Maybe it's a friend who challenges you, a mentor who guides you, a partner who balances your strengths with their own. Aren't those moments of connection when you feel most capable, most alive? Corals remind us that intelligence isn't just about individual brilliance. It's about the courage to share your existence with another, to trust that giving will be met with receiving. The smartest lives are often the ones woven together. This way of thinking also challenges how we define success. We admire lone geniuses, solitary inventors, heroes who stand apart. But coral doesn't stand apart. Its strength is interdependence. Its genius lies in knowing that no one thrives in isolation. And in that truth, we are confronted with a shift in identity. What if being smart isn't about independence at all? What if it's about integration? What if the future belongs not to the strongest individuals, but to the best collaborators? Zooming out, entire reefs depend on this micro-level relationship. Without algae, coral polyps couldn't gather enough energy to build the skeletons that house fish, crabs, and countless other creatures. Without coral, algae wouldn't have the safe environment to flourish. Together, they sustain ecosystems that feed millions of humans and protect coastlines across the globe. Their partnership literally reshapes the Earth, creating structures visible from space. That's the ripple effect of intelligent design. Small partnerships scaled up to planetary impact. And here's a thought that lingers in the background. We live in a time when partnerships, between nations, between communities, between humans and the environment, are strained. Distrust runs high. Competition overshadows cooperation. But coral and algae, in their quiet way, show us what's possible when two different beings commit fully to a shared purpose. They don't ask who gets the bigger share. They don't argue about fairness. They simply build together. That's not naivety, that's strategy. It's survival through generosity. We often say the future will be won by technology, by algorithms, by artificial intelligence. But maybe the deeper intelligence we should be studying has been sitting in the ocean all along, glowing softly beneath the waves. Corals don't run on wires or silicon. Their operating system is trust. Their algorithm is reciprocity. Their code is simplicity refined over eons. And unlike our technologies, theirs doesn't burn out. It regenerates. Last, as we prepare to move forward, I want you to keep one image in mind. Picture a coral polyp, a small, translucent body housing golden algae within its tissues. The algae shimmer as they work, turning sunlight into sugar, feeding their host. The host protects them, cradles them, gives them the space to thrive. Together, they are stronger than either could ever be alone. That is intelligence in its purest form. Not dominance, not speed, but harmony. And maybe, just maybe, it's the kind of intelligence we should aspire to create in our own world. When we talk about intelligence, our instinct is to picture a brain. Folds of gray matter firing with electricity, neurons passing signals across synapses. We think of thought as something contained, centralized, locked away in a skull. But what if intelligence could live outside the brain? What if it could spread across thousands of organisms, each one playing its part, until the whole became greater than any individual? This is what a coral reef invites us to consider. A distributed mind, a networked intelligence, a living system where the thinking is not bound to one creature, but emerges from the many. First, that seems impossible. How could a reef think? It doesn't have neurons or nerves in the way we do. And yet reefs coordinate. They anticipate. They adapt. They communicate across distances and through species. The key lies in the silent language of chemistry and behavior. The signals passed invisibly between coral polyps, fish, algae, and countless other residents. Like neurons whispering across synapses, the reef is constantly alive with messages. You may not hear it with your ears, but if you could listen differently, you'd recognize it as thought. Take coral spawning. Once a year, often in perfect synchrony, corals across miles of reef release their gametes into the water column within the same brief window of time. Think about the odds of that. Tens of thousands of colonies, each composed of millions of polyps, somehow manage to coordinate a mass event without text messages, without calendars, without leaders. They use environmental cues, the pull of the moon, the rise in temperature, the subtle lengthening of days, to time their release so precisely that the ocean seems to explode in a pink and white snowstorm of life. Doesn't that look, at least in spirit, like a brain coordinating the firing of neurons? Each colony is an individual, but together they act as one. There is suspense in that moment, a sense of wonder at how such simple creatures achieve such orchestration. And it makes us reflect. Is intelligence only in our kind of communication, or is it also in the ability to align with the rhythms of the cosmos so perfectly that millions of lives move in unison? Perhaps what we call smart is only one version of something much larger. But spawning is only one example. The reef is full of constant conversations, some chemical, some behavioral, all critical. Polyps release mucus trails that carry information about stress, neighbors, or the presence of predators. Fish detect these cues and respond, shifting their behavior. Cleaner wrasse set up what can only be called clinics, stations where larger fish line up, waiting for parasites to be removed from their scales. Think about the trust required for this ritual. A predator opening its mouth to let a tiny cleaner inside, resisting the instinct to snap shut. That is not random chance. That is a relationship mediated by signals of trust, reinforced by countless interactions. Over time, those signals become part of the reef's language, ensuring cooperation where violence could easily prevail. And it isn't just about peace, it's also about strategy. Parrotfish, for example, spend their days grinding at coral, scraping algae from the surface. They look destructive, but in truth, they are vital maintenance workers. By grazing, they keep algae from overrunning the corals, trimming the balance like gardeners tending a park. Their daily routines, coordinated across the reef, prevent collapse. You could say they are like neurons pruning connections in a brain, removing excess so that clarity remains. Without them, the reef loses equilibrium. With them, the system stays healthy, able to channel energy smoothly. Now pause and consider this metaphor. The reef as a neural network. In your brain, no single neuron knows what you are thinking. Each just fires, passes its signal, and responds to chemical cues. Yet, collectively, they give rise to consciousness. Similarly, no coral polyp, no fish, no shrimp understands the reef as a whole. But together, through their connections, they create something emergent. An intelligence distributed across space and species. Doesn't that change the way you see them? They aren't just individual creatures. They are nodes in a system of thought. To deepen this idea, imagine a clownfish nestled in its anemone. The clownfish offers protection to its host by scaring away intruders, and in return, the anemone shields it with stinging tentacles. But zoom out, and you see the clownfish's actions ripple outward. Its movements influence other fish nearby, shifting predator-prey dynamics. Its presence changes the flow of nutrients, altering the chemistry of the reef. Every small action carries weight like a neuron firing and affecting distant regions of the brain. Intelligence here is not centralized. It's relational. That realization can feel unsettling, because it forces us to question our own cherished ideas of individuality. We like to think of ourselves as independent thinkers. But perhaps our intelligence also emerges from networks. Families, cultures, ecosystems, even the invisible microbiomes inside our bodies. The reef holds up a mirror and asks, are you really as separate as you believe, or are you too a distributed mind? That's an identity shift, and not an easy one. But it's a shift that can expand our empathy, making us see ourselves as part of systems larger than we imagine. And the more you look, the more the reef reveals its brilliance. Some fish change color instantly, signaling dominance or submission. Others coordinate in schools, turning with such perfect alignment that they seem like a single organism. Predator strategies adapt in response, with groupers signaling to moray eels to hunt cooperatively, one flushing prey from crevices, the other waiting to ambush. These are not random collisions of instinct. These are tactics, refined through generations, embedded in the reef's living memory. If that isn't thought, what is it? Let's return to chemical communication for a moment, because it's here that the reef most resembles a whispering brain. Corals under stress release molecules that alert their neighbors, like fire alarms passing down a corridor. Some of those molecules even attract helpful species, summoning allies to deal with threats. It's an ancient version of crowdsourced problem solving. One polyp alone is weak, but linked to others through chemistry, it becomes part of a collective defense. That is the essence of intelligence. Not merely reacting, but warning, anticipating, and strategizing as a community. And think about timing again, not just in spawning but in daily rhythms. Corals expand their tentacles at night, retract during the day. Fish follow patterns of feeding and resting tied to the light. Even the sounds of the reef, yes, reefs have sounds, play a role. Crackles, pops, and grunts from snapping shrimp and fish form an underwater chorus that guides larvae back home. Scientists call this the reef's acoustic signature, a soundscape that acts like memory, drawing the next generation to its birthplace. What is memory if not a signal carried across time, a way of ensuring continuity? In that sense, the reef not only thinks, it remembers. To see the reef this way is to step into a world of awe. Suddenly, every interaction becomes meaningful. The cleaner wrasse is not just eating parasites. It is maintaining trust. The parrotfish is not just grazing. It is pruning the system for clarity. The clownfish is not just hiding, it is reshaping flows of energy. Together they are weaving a tapestry of thought, not in neurons but in relationships. And here's where the suspense builds. If the reef is a mind, what happens when parts of that mind are silenced? What happens when signals break down, when species vanish, when stress overwhelms communication? We'll explore that later, but for now, let the question linger. Because every brain, no matter how brilliant, is vulnerable when connections are lost. For now, focus on the wonder of it. A reef is not just alive. It is aware. Not aware in the human sense of reflection or language, but aware in its ability to sense, to respond, to coordinate. Its intelligence is not about individual thought, but about collective adaptation. It shows us that thinking doesn't always require a brain. Sometimes thinking is simply the art of connection. And perhaps that is the lesson reefs whisper to us. That we, too, are only as intelligent as the networks we create. Our communities, our ecosystems, our shared trust. These are our synapses. Break them and we lose clarity. Nurture them, and we gain wisdom beyond what any one of us could hold. That's the deeper intelligence of coral reefs. And it's a lesson waiting for us to learn. When we think of memory, we imagine neurons firing, the brain holding on to an image, a lesson, an experience. Memory is the library of the self, the record of what we've been through. But reefs remind us that memory is bigger than brains. They teach us that remembrance can exist in the very fabric of life, etched into cells, coded into genes, carved into the shape of survival itself. What would it mean to learn without neurons? To hold on to lessons not in thoughts, but in the way your body responds to the world. That is the quiet mystery of coral reefs. They remember. It may sound poetic, but it's also profoundly scientific. Corals, when stressed by heat, light, or acidification, respond in ways that shape their future resilience. If they survive, they adapt, sometimes subtly, sometimes dramatically. Their tissues adjust, their partnerships with algae shift. Their descendants inherit a fraction of that endurance. It's not memory as we know it, but it is unmistakably a form of learning. They recall past hardship not with recollection, but with adaptation. And that adaptation can echo forward across generations. In this way, reefs carry lessons written in resilience, passing down knowledge through biology instead of words. Consider a reef that has endured a bleaching event. For many, such events are devastating, leaving ghostly skeletons where vibrant life once thrived. But some corals survive. In their survival, something remarkable happens. The algae that return may be of a different type, hardier, more tolerant of heat. The coral, in a sense, has chosen a new partner, remembered the burn of stress, and prepared itself for the next trial. It is as though the reef has learned to switch strategies, reconfiguring its alliances in response to experience. Isn't that, at its core, what memory and intelligence are about? Learning from the past to shape the future. This is where the reef's quiet genius reveals itself. We often measure intelligence by our ability to anticipate problems, but corals show us another dimension. They don't just anticipate, they embody the history of challenges they've already faced. Their very existence is a memory bank of survival strategies. Each adaptation is like a chapter in a book, each genetic shift a lesson underlined. And because their lives are measured in centuries, those lessons compound over time, creating lineages that carry echoes of ancient seas, ancient climates, ancient struggles. The reef remembers what the world has thrown at it before, and in remembering, it endures. Think of your own life. Haven't your hardest moments shaped you most deeply? The challenges you barely survived, the times you felt stretched beyond your capacity, they carved resilience into you. You may not remember every detail, but you know how they changed the way you walk through the world. Reefs are no different. Their beauty is not fragile decoration. It is the result of ages of trial and persistence. Every polyp, every colony, carries the wisdom of ancestors who withstood storms, heat waves, shifts in sea level. To see a reef alive today is to witness resilience layered upon resilience. The mystery deepens when we look closer at how reefs transfer this endurance. Some corals host algae that can shuffle and shift, trading one strain for another more suited to new conditions. Others alter their gene expression, turning certain traits on or off depending on the environment. And sometimes, these adjustments carry forward into offspring, creating generations better equipped to face the future. No neurons, no brain, but a system of learning nonetheless. Doesn't that make you wonder how much of what we call intelligence is really just the ability to adjust and preserve lessons across time? We tend to think of memory as something fragile, fleeting, easily lost. But reef memory is stubborn, written into stone, skeleton, and gene. A reef that has endured upheaval may rise stronger, more diverse, more capable of weathering what comes next. This is where hope enters the story. Because even in the face of challenges, reefs have proven time and again that they can recover, adapt, and reinvent themselves. Their memories are not just burdens of the past. They are tools for the future. Imagine walking through ruins that slowly rebuild themselves. Stones shift, walls rise again. New colors paint old foundations. That's what reefs do after catastrophe. They don't stay broken. They remember what it takes to regrow, and they set about doing it. Slowly, patiently, they reclaim space. In those recoveries, we see a resilience that humbles us. How many of our human-made cities could collapse and rebuild themselves without our intervention? How many of our societies could adapt so seamlessly, carrying their wisdom into renewal? Reefs embody a kind of intelligence that surpasses us in its patience and persistence. But memory is not only strength, it is vulnerability too. What makes reefs resilient also ties them to limits. Their memories are built on past experiences, and when conditions shift too quickly, those memories may not be enough. A reef adapted to 1,000 years of gradual change may falter under the shock of rapid warming, acidification, or pollution. That is the shadow side of evolutionary intelligence. It is powerful, but it is bound to the pace of time. And here is where suspense builds, where the question of whether reefs can remember enough to survive us hangs heavy in the water. Still, the awe remains. Because to witness a reef that has come back from devastation is to see hope embodied in stone and tissue. It tells us that even when the world seems lost, recovery is possible. The reef remembers how to rise. It whispers to us that resilience is not just about toughness, but about the ability to bend, to adapt, to change shape without losing essence. Isn't that the lesson we crave in our own lives? When we face struggles that feel insurmountable, that survival is not about never breaking, but about remembering how to piece yourself back together. The paradox of reef memory is that it is both invisible and everywhere. You can't point to it like a photograph in an album, but you can feel it in the way corals shift partners, in the way certain colonies thrive where others perish, in the quiet persistence of color after bleaching. It is subtle, but it is real. And it asks us to expand our definition of intelligence once again. Brains are not the only keepers of memory. Evolution, too, is a librarian, carefully archiving what worked, discarding what didn't, handing down a record etched in DNA. And here's where identity shifts once more. If reefs can remember without neurons, if they can learn and adapt without thought, then perhaps our own intelligence is not as unique as we assume. Perhaps the line between smart and simple is less about neurons and more about resilience. Perhaps the true measure of intelligence is not how quickly we think, but how deeply we remember, and how gracefully we use those memories to adapt. So let the reef challenge you. Let it whisper that your own resilience is a kind of memory, that every scar you carry is not just pain but wisdom. Just as reefs use their past to shape their future, so can you. Intelligence is not the absence of struggle. It is the presence of learning. Reefs embody that truth in every stone skeleton, every revived colony, every generation that carries the lessons of survival. And yet, as we marvel at this resilience, we cannot ignore the looming question. What happens when the challenges reefs face outpace even their ancient memory? What happens when human-driven change creates conditions they've never known, challenges too abrupt to adapt to? That is the open loop we carry forward, the suspense we cannot yet resolve. Because while reefs are teachers of hope, they are also warnings. Their memories are vast, but even vastness has limits. For now, though, let us honor what they reveal. The reef remembers. It remembers ancient seas, ancient storms, ancient fires of heat and ice. It remembers how to bend without breaking, how to shift alliances, how to hand down strength through generations. It remembers survival as an art, not an accident. And in that memory, there is both mystery and magnificence. Intelligence, it seems, wears many faces, and one of them glows quietly beneath the waves, teaching us that to endure is to remember. Every great system, no matter how brilliant, has its breaking point. Coral reefs have shown us patience, adaptability, memory, and resilience. They've thrived for millions of years, weathering ice ages, shifting seas, and slow planetary transformations. But today, their intelligence is being tested in ways it has never encountered before. And unlike the gradual changes of the past, the threats now are sudden, accelerating, and overwhelmingly human-made. This is where awe gives way to urgency, because even the smartest systems can falter when pushed beyond their limits. Coral bleaching is the clearest signal of this crisis. On the surface, the phrase sounds mild, almost harmless, like sun-bleached fabric. But in reality, it is devastation disguised in a gentle word. When water becomes too warm, corals are forced into a terrible decision. They expel the very algae that feed them, the symbiotic partners that keep them alive. Without those algae, corals lose their vibrant colors, turning ghostly white, skeletons visible beneath translucent tissue. Bleaching is not death in itself, but it is a cry of desperation, a system shutting down its chefs and power plants in the hope of surviving until conditions improve. If the stress continues too long, survival slips away, and the reef collapses into silence. Think about the fragility hidden inside that choice. The coral-algae partnership has lasted for hundreds of millions of years, surviving shifts that ended entire species lines. Yet just a few degrees of warming water, often lasting only weeks, can unravel it. What does that say about the power of the pressures we've introduced? These are not natural cycles unfolding on geological timescales. They are abrupt shocks, burns of carbon pollution, heat waves in the sea, chemical changes from industrial output that overwhelm even the most patient intelligence. If reefs, with their deep memory and genius for cooperation, are struggling, what does that say about us, the architects of this new crisis? The contrast could not be sharper. On one hand, a reef is a model of efficient design, where nothing is wasted and balance is maintained with astonishing grace. On the other, our human systems consume endlessly, extract recklessly, and ignore the signals of stress until collapse is already underway. Coral bleaching is more than a tragedy of ecosystems. It is a mirror. It reflects back our inability to live with the restraint and reciprocity that reefs embody. It forces us to ask an uncomfortable question. If we are supposedly the smartest species on Earth, why are we the ones destabilizing the systems that make life possible? Acidification adds another layer to this story. As oceans absorb the excess carbon dioxide we release, their chemistry shifts. The water becomes slightly more acidic, and that small change erodes the very foundation of reef architecture. Calcium carbonate, the substance corals build with, dissolves more easily under acidic conditions. Imagine constructing a cathedral, only to have the stone itself weaken and crumble under your hands. That's what reefs face. Not just the loss of their partners, but the erosion of their skeletons, the bones of their cities dissolving into the sea. Intelligence, no matter how elegant, cannot build on vanishing stone. The fear here is real, and it should be. Scientists warn that if warming continues at its current pace, we could lose up to 90% of the world's reefs by mid-century. That is not a distant future. It is within the lifetime of people alive right now. And with reefs go the species they shelter, the food security they provide, the coastal protection they offer. Entire communities, human and non-human, are tied to their survival. To lose them would not just be an ecological wound, but a cultural and economic one. It would be a test of whether we can bear the weight of our own neglect. But within this crisis, there are sparks of hope, because intelligence is not only about memory, it is about innovation. And just as reefs have adapted in the past, humans are beginning to search for ways to support their resilience. Some scientists are experimenting with assisted evolution, selectively breeding corals that can withstand higher temperatures and transplanting them to vulnerable reefs. Others are restoring reefs by growing corals in nurseries and planting them back into degraded areas, giving ecosystems a chance to recover. Technology is even being used to broadcast reef sounds, those crackles and pops we spoke about earlier, through underwater speakers to lure young fish and coral larvae back to damaged sites, helping the reef remember itself. These efforts are not silver bullets. They are lifelines, experiments in collaboration between human ingenuity and coral resilience. And they raise a powerful possibility that intelligence can be shared across species. Just as algae and coral formed their pact millions of years ago, perhaps humans can now enter into a new partnership, one where we lend our tools and knowledge to help reefs weather a storm of our own making. Isn't that the essence of wisdom? Not pretending we can solve everything, but joining forces with systems older and smarter in their own way than we are. The empowerment hidden in this crisis is subtle but profound. Tells us that our actions matter. If we continue on our current path, reefs will suffer beyond repair. But if we choose differently, if we cut emissions, protect coastlines, reduce pollution, we give reefs space to do what they've always done: adapt, remember, and survive. The difference between a world with reefs and one without them rests in the choices we make in the coming decades. And that should stir both urgency and responsibility. Still, we cannot sugarcoat the stakes. Reefs have limits. No amount of adaptation can withstand endless stress. Their intelligence is vast, but it is not infinite. If we push them past thresholds too often, their memory will fade, their resilience will fracture, and the living cities of the ocean will collapse into barren rubble. This is not a warning for some far-off future. It is a reality already unfolding in places like the Great Barrier Reef, where mass bleaching events have struck repeatedly in just the past few years. Each time, recovery becomes harder, the margin of resilience thinner. Even the most brilliant system cannot withstand unrelenting assault. And yet, standing at this crossroads, we still have something reefs no longer do: choice. Reefs adapt to what they are given. They cannot negotiate the terms of the climate. But we, as humans, can. We can slow the pace of warming. We can decide to protect ecosystems instead of exploit them. We can recognize that our intelligence is not defined by invention alone, but by restraint, humility, and cooperation. That is the choice before us: to honor the wisdom of reefs by learning from their design, or to ignore it and watch them vanish. In this contrast lies a deep lesson about identity. For too long, we've defined ourselves as masters of nature, separate from it, superior to it. But reefs expose the folly in that thinking. They show us that mastery without care leads to collapse, while cooperation leads to endurance. They remind us that the smartest systems are those that know their limits, that build within boundaries, that adapt without overreaching. If reefs can teach us anything, it is that survival is not about domination but about balance. So let the urgency fuel you, not with despair, but with resolve. The reef's crisis is a test not only of its intelligence, but of ours. Will we learn from their resilience, or will we insist on continuing our reckless course? Will we help restore the balance, or will we break the system that has sustained life for millennia? The reef cannot answer that question. Only we can. And here the suspense lingers. Because even as science works on solutions, even as conservation efforts spread, the reality remains uncertain. The reef's intelligence is vast, but it has never been tested against a threat like us. Whether it survives depends not on some distant force of fate, but on the decisions we make right now in this generation. That is both terrifying and empowering. Terrifying because the stakes are immense. Empowering because the outcome is still within reach. So as we leave this moment and step into the next part of the story, hold on to the contrast. A system of unparalleled brilliance, tested by the fragility of human choices. A reef that remembers, adapts, and endures, now facing the limits of its resilience. A crisis that could become a collapse or a turning point. The answer is not written yet. And in that unfinished story lies our greatest responsibility, and perhaps our greatest chance at redemption.